Okay. Um, why don't we get started? It's a couple minutes past the hour, and we wanted to welcome everybody to. I think this is our fifth season of the networking channel and opening 2024, and we're really excited. We've got a great program for actually putting together for the entire season for the spring semester, and we're really pleased to be able to kick this off with Marwan Fayed, who you can see, I think, down there in the corner of his screen. We're doing a really super advanced Zoom here with a new feature on the Mac that we're going to try out today. But we're really thrilled to have Marwan here. He's going to talk about Cloudflare in the context of CDN services. He's going to talk about architecture, research problems, and operations. It's going to be, I think it's going to be a really great.
This is also first. This is the first time people manage to contain Marwan in a small circle like that.
Yes, he's stuck in a little corner down there in the box, but otherwise we wouldn't really see his video except over in a little square box in the video channel here. So actually this looks pretty good. So let me introduce Marwan to folks, and then just say a couple words again about the format of the day. So Marwan's a technical lead and he's a manager at Cloudflare Research. He's been a faculty member at the University of St. Andrews in the UK, and he's a visiting professor there still. He was also director of postgraduate studies, and when he was at the University of St. Andrews, he's a fabulous teacher, won awards for that, and honors for supervising students as well. In 2011, Marwan co-founded Hubs, which is a cooperative community backhaul ISP that received awards at both the national and European level for technical excellence and innovation and advocacy, and still going today. So Marwan's research interests are in edge networks and secure, private, and reliable protocols, network measurement. He's the author of many papers, recipient of an IEEE Best Paper Award, and a senior member of both IEEE and ACM. So we're really thrilled to have Marwan kick things off for our fifth season. Let me remind everybody that Stavrula has posted in the chat, so take a look at chat. The conversation that's going to start today with Marwan's presentation continues on in Slack, so you can join the networking channel Slack channel. And let me remind folks also, we're going to have time at the end for comments and questions. So please utilize the chat feature. You can, if you've got comments and questions, you can enter them in chat, and you can also enter them in chat or in the Q&A. And Christophe and I, the organizers of this particular session, will be monitoring both of those. So anything else to add, Christophe, before we hand things over to Marwan?
No, I'm sure Marwan will go over time, so it's better to start early.
Okay, well, actually, a reminder to everybody, we never go over time, and so we will stop. And Marwan's made time for questions at the end, and we want to tell you about some of the upcoming events. So we will finish on time. Okay.
Overtime is on Slack.
Right, overtime's on Slack. Great. So without any further ado, Marwan, let's hand it over to you. Thanks again for being here.
Thank you both. I'm entirely honored for the invitation. I'm going to dive right in, whip through the first few set. My own, just to give a sense to people, my own motivation for doing this. When I joined Cloudflare, there were a number of things that I was exposed to and thought to myself, that's not possible. Or ended up being involved in building and designing things that typically we think are not the way of the world. And I get exposed to this when I write and I communicate outward, and people say, no, that's not the way it works, or that's not an important problem, or, you know, and so one motivation for doing this is to expose people, at least in principle, to some of the things that are actually happening behind the scenes here. Also explain what a network that, like Cloudflare looks like, because not all CDNs are equal. Many of the pieces that I put in this presentation deserve a lot more detail in their own right. I've provided pointers where possible. Of course, I'm happy to carry the conversation forward. But I also want to leave time at the end for things that a little bit of look ahead. I think, in a sense, sort of depending on your perspective, threats or opportunities for internet and internet-related research that I think are worthwhile. So let me first say Cloudflare has an internship program, and this is across disciplines, so it's not just in the technical domain. And I would encourage people to visit the careers site. I'm not sure if all of the internships have opened just yet, but these span the gambit: research, engineering, marketing, all of the rest. So please, by all means, spread the word. First, let me give you a high-level view of what Cloudflare looks like, just to give a sense of people of what we're operating with. The research and the engineering at Cloudflare is very much about scale. So we do have a little research group in the company, which I'm a part. And when we think about the value proposition, because the research group at Cloudflare is neither product nor revenue driven, we tend to think of ourselves as sort of putting things to the test, because bizarre things happen when we actually build and deploy them. But you can see here from the numbers that it's a rather large network. And so small things really, really start to show up, as do mistakes. A couple of interesting things about this is people have a view that Cloudflare is mammoth. I suppose it's true as an operation, it's substantial, but the number of people who are employed at Cloudflare that are behind all these numbers is about 3,500 last I checked. And if people are interested in seeing a little bit more about research in general at Cloudflare, by all means, there's a whole website devoted to it, research.cloudflare.com. Okay. Also, if anyone is interested, I'm sure many in the room are probably already aware of this, but just in case, Cloudflare works really hard to make more and more data available where possible, and that's all at radar.cloudflare.com. There's the beautiful UI that designers have put together, but there's also an API, if you look in the lower left here, that people have access to. Okay. All right, so now just a little sidetrack here. I suppose stems from teaching days, and I'm sure I'm not the only person to take this position, but it's also always useful to understand the why in computer networks. So this is a very personal view. When we teach about computer networks, and there's always questions, and I find, look, anecdotally, 9 times out of 10, when trying to understand why things are the way they are, the answer tends to relate to scale. But this begs the question is, what about the 10th time? And I claim, and I hope that many will agree, is actually comes down to money. BGP is a perfect example of this. BGP is less about being optimal and more about representing business relationships. Okay, but that spans out across design in the network, in the systems. But there's this added element that I'm going to throw in from the notion of content distribution and delivery. When we think about what and how, I find it helps to think about things in terms of connection termination, not packets so much, which is how we tend to think about things about layer 3. In the panel back in November, there was a comment that there's no monetization in the internet. Packets aren't worth anything, and it's absolutely true, but connections are. So this is useful to keep in the back of the mind as we proceed. So let's look at Cloudflare from the outside. Cloudflare fundamentally it's a reverse proxy network that uses global anycast. And I want to give a brief overview of both, although probably injustice to the level of depth, but we'll try. So when someone ends up requesting something that's available via the Cloudflare network, what happens is there's a DNS query that goes to the authoritative DNS service at Cloudflare. And this is how Cloudflare injects itself into sort of the content path. The origin server delegates its authoritative DNS to Cloudflare. Okay, so the DNS query comes to Cloudflare, an IP address goes back, and then the client initiates the request to Cloudflare's edge servers. Goes through the denial of service protections, the firewalls, HTTPS for virtually everything these days. If something is in the cache, it gets served back. If it's not, it goes out to the origin server, and then the content is returned to the client. And I want to be very clear about something here. Cloudflare as a reverse proxy, Fastly is in this space, Akamai is in this space, is never the source of truth. So when we do things like measurements and we say so much content comes from Cloudflare and so much from Fastly and so much from AWS or GCP, Google Cloud Pages, we have to be rather careful because in a sense, there's an element of what may be double counting in there. So even though the content comes from a Cloudflare server, The content itself and the nature of the content is all held and managed by the origin. Okay, if we're lucky, it's cached on the edge, but that's not always the case. That's the first thing to point out here about a system like Cloudflare. The second, of course, which I think is really useful, is to talk about who is the customer. So we tend to use the word client, and client can go either way. Within a Cloudflare context, just to level set jargon, if I say client, I'm referring to the actual user at the machine requesting content, sometimes the eyeball we say. And the customer is, remember, follow the money. That is the entity that pays Cloudflare, which is the origin servers, okay, the domain owners. So I'm going to pause here for a moment and talk about, Cloudflare having injected itself in the middle. What does this say about the end-to-end principle that we sort of value in the ideal in the network? And it's worth thinking about. Just as a reminder, the end-to-end principle says application-specific features reside in the end nodes and not in the gateways and the routers and the other intermediary nodes. Okay. Well, the funny thing is, we kind of think as these services is breaking the end-to-end principle, but I'm not so sure that that's true. I think it's still E to E, how we've abbreviated. It's just that the second E has become edge, because there's still a nature of connection semantics here. There's a client that initiates a connection and a server that terminates the connection. What it takes to get the content ultimately differs slightly. So maybe it's in the cache, or very often what happens, it's not available at the edge server, so you have to go out to the source of truth via a second connection. Okay. Sometimes if you're a high-paying customer, for example, you might decide to use the network within the edge service in order to get to the content faster. And there can be anyone, like I said, as is pointed out here, from 1 connection to 3 connections. For some services, even within the data center, you'll form many more connections to produce content, and you can have 6 or more IP addresses involved. Okay. So I claim E to E remains, it's just that the nature of the second E maybe is a little bit different. Okay. The second piece is that Cloudflare operates anycast for all content, not just DNS. Now, I will admit, I remember when Cloudflare first launched and I sat down with a bunch of my friends in academia and the IETF and I said, hey, this Cloudflare outfit, they're going to throw out a bunch of commodity services and run anycast for everything. There's all kinds of reasons that's just not going to work. And I think Cloudflare has sort of proved that notion wrong, at least so far. So what does this mean? Jim asked me for sort of a background slide about this. Imagine you're a client and there's a bunch of servers around. If you're in the unicast space, they each have their own IP address and there's one path to get to the destination. If you're in an anycast system, the same IP addresses might be advertised out to the internet from multiple locations, and then via BGP routing, your packets will be taken to the closest one. Okay. So an anycast address, even though it's a single address, lives in many places. And I want to quickly demonstrate this. If I do, this is a few months ago, I do a DNS query for cloudflare.com. I get these 2 addresses back. Incidentally, this is for resilience in case a path to on one of these fails, the other one is available. If I know Christophe is in the room, I just happen to take Google because everybody knows Google from 2 different sides of the Atlantic. So this is me visiting family on one side, and this is me working on the other side. And you'll see there's 2 completely different addresses. Now, these themselves might be anycast addresses within the region, but on different sides of the Atlantic, they're clearly very different. But just to demonstrate that if I now take a packet and try and route it, I find the path to the destination, you can see from the west side of the Atlantic over in North America, if I do my trace route, I get to the Internet Exchange, the Cloudflare POP in Toronto for the same address as I do on the UK side, where if I do the trace route from up in St. Andrews, for example, I get down to the POP in Manchester, again, same address, okay? So this is anycast in action. Just wanted to make sure that everybody visible here. One of the benefits of the anycast idea is that you will always stay close to the eyeball. So always, we hope, BGP routing will take you to the closest destination by some measure of closest. But nothing comes for free. We all operate in the system's domain. So what do we lose here? Well, we lose the visibility on the longer paths. They're just when we talk about going from Cloudflare to clients, for example, or vice versa, these long paths are very, very hard to find because of public routing. Something to keep in mind when we're thinking about doing research and measurement. One other thing I want to throw out that is rather interesting about the Cloudflare setup is that Cloudflare has a free tier of service. Okay, so there are other tiers, flat rates, and then the enterprise, which is some contract, of course, that gets negotiated. But this free tier is important. It means anyone can decide to throw out a server, a web server in their bedroom closet, and then put that service behind Cloudflare for absolutely nothing, no dollars. Okay, this is going to become important in a moment. So now let's look at Cloudflare from the inside. There are 4 things I want to hone in on. $0 egress, and I'll explain what that is and why it's important. A single software stack, this notion of 70% CPU load, and what I affectionately call the glob mogs. Okay. So first is egress pricing. Now, remember I said there's a free tier of service. That also means in the free tier of service, it gets coupled with the $0 ingress and egress. Now, you put these things together, what it means is you could conceivably be the most popular website on the planet, put your content behind Cloudflare, and pay absolutely nothing to get the benefits of denial of service protection, some caching, and so on and so forth. Now, it's not to say somebody won't call and say, hey, you're generating a lot of load on the system. Can we discuss some kind of, I don't know if or when or how that happens, but in principle, there are very popular things that actually get the benefit of service for and pay nothing in return. Part of this is the ethos of the company, genuinely believes it's part of the infrastructure and everyone should be able to have sort of a level set basic level of service. I know that's a lot of marketing speak, okay? But for 2 reasons this matters. The first is not everyone operates this way. So the caveat here is if you're hosting content at a place that charges egress, then that's something to keep in mind. And one of the reasons you would sign up to Cloudflare is to say, I want to reduce my egress costs coming out of my hosting entity. And so it's really important that Cloudflare's cache works well for me. Now, this begs what I think is an interesting research question, an opportunity to devise a whole new set of metrics around the notion of value to the paying customer. And it's genuinely an open question. I know there is some work that has sort of started down this stream, but if you're operating at Cloudflare, and let's say just the simple case, your cache is full, you need to evict something, we have methods that say, the largest object, the least recently used, all of these common types of things. But what if instead there was a notion of, I want to evict the thing that is going to save some customer the most money in the end? And that raises all kinds of interesting questions. So just flagging this one. The second one is the single software stack, which is different from the classic data center model that is more familiar, where there's a connection termination server, and then there might be a bunch of work in the background, all the microservices, one to generate ads, one to retrieve an image, and so on and so forth. Well, at Cloudflare, one of the ways that it has managed to remain agile and grow is that every server has the exact same software stack. So an engineer at Cloudflare writes a single line of code, and that goes to every server always. This is the working model. Now, there may be exceptions in the system. Of course, there must be, but that is never the rule. The working model is every line of code goes to every machine. So just to talk about what it looks like here, here's the gray encapsulated region is the data center. Connection comes in. There's an ECMP router that will fan out to one of the servers in the system. Goes through the DOS protections once it's on the server, and then it hits the layer 4 load balancer, which I'm going to come back to in a moment. After that, you get proper connection termination, and then the suite of applications. So maybe it's a DNS query, maybe it's just straight HTTP for content. There's the serverless product, and the list goes on and on. If there's if there's content, then we go looking for the cache, and if it's not there, then there's a connection that's made out to the origin. Okay. This is, in a sense, unique. It's exciting and it's dangerous. And so we have to think a lot about how to safely deploy code, because one line of code can make life difficult for everybody as a consequence of this. And one of the places that shows up, of course, is that Cloudflare, in order to make the best use of its resources, it decidedly runs its CPUs at 70%. Now, this is more and more common with the large operators. Google has a great online document about how they've managed to do this and how they keep track of it. But think about 10 or 15 years ago, this was largely unheard of because of notions of performance evaluation in the conventional sense. So taking the performance evaluation, I remember this from way back when, for reasonable assumptions, you tend to find that 70% load is this dangerous operating point, because if you push past it too far, then you start risking the notions of service degradation. And so the best practice was always you want to operate CPU at 30 to 40% in order to leave some headroom. But I'm going to point out, actually, these old models also date back to a time of rotating hard drives and are worth revisiting. But this is something that we always have to keep track of here at the company. So Cloudflare cares a lot about CPU, but of course not uniquely about CPU. Also tries to do as much as possible at the edge instead of sort of offline in the core. But of course, that doesn't mean that everything and anything goes to the edge as a consequence of this sort of fragile operating point. Okay. Now I want to come back to the load balancer. How do you manage a global anycast network? Well, there's two pieces I want to point out here, and I would love to be able to dive in further, but instead I'm just going to give you a sense of what these things do and how they operate, and then point you to at least the blog. This is being written up, of course, for peer review. So there is a feature internally called Unimog, and this is the name of the layer 4 load balancer. Traditionally, when we think of layer 4 load balancers, the classic example, the first to really publish this and make it known, was Google's Maglev from NSDI a few years ago. And there's a whole set of machines where connections come into, and those machines are responsible for balancing load across servers in the data center. But remember, at Cloudflare, I said every machine operates a single software stack. And what that means is every server that does DNS and that does caching and so on and so forth and DOS protections also is part of the layer 4 load balancer. Okay. Now, there's a brilliant blog about this. It's one of my favorites, to be honest. This is one of the things that blew my mind just after I joined as it was released. It's novel because it's stateless. If you're interested in the implementation, it's written with XTP. From a feature perspective, thinking about this architecturally, this is what it means. Connection comes into ECMP router, it hits one of the servers at random, and then the layer 4 load balancer will decide whether to redirect the connection. Now, it's a little bit unfair that I say that because it actually doesn't decide at all. The trick here is it always redirects. No ifs, ands, or buts. And that's one of the keys to being stateless. Because the alternative is you have to keep track of the load of the CPU on your server and every other server. And there's a lot of latency that you inject in trying to keep that kind of state. So the rule is no matter where it comes in, send it on to a different server. No ifs, ands, or buts. Remember I said there's oftentimes things are driven by money. Well, why do we do this? First, the single software stack, it's important. Don't want to throw out a whole bunch of servers that do something different. The second is this ECMP router here. It is a big enterprise grade box. It has a hash function embedded with it that cannot be changed. And so if the hash function that's in the machine does not work for the workload, that what ends up happening is the load is skewed onto a subset of the machines in the system. And so this is Cloudflare's way of redistributing load within the system, okay, called Unimog. But now this opens up a new opportunity. And this gets into something we call Plurimog, which is an extension of the Unimog system, coupled with a little thing we call Traffic Manager. And what this says is, if the whole data center is running hot, if all the machines are really loaded, then this load balancing system here will actually redirect those connections outside of the data center to a different data center. Now, the reason this is important is the following. Cloudflare, remember, operates a global anycast system, not a regional one. So the only way to shift traffic from a data center, in this case, we've got Philadelphia and Ashburn, okay? If there's load coming in and Philadelphia is running hot, the only way to redirect traffic to Ashburn is to withdraw the routes completely from Philadelphia. So this data center would stop advertising routes to this data center, and all connections that would have gone there will now go somewhere else, Ashburn or somewhere else nearby, all decided by BGP, okay? Instead, what happens with Plurimog is those connections continue to be routed to Philadelphia, but because the load balancer is so high performance, nominal cost on the CPU, if the whole data center is running hot, then Plurimog, by instruction of this traffic manager thing, will redirect those flows to some other data center that will actually do the connection termination. And then the responses back to the client, even though you might think they're coming from Philadelphia, are actually coming from Ashburn in this case. When we're thinking about doing things like measurement, you want to understand the performance of Cloudflare, you're doing a bunch of pings, and you see, I don't know, most times you're 50 milliseconds, but every now and then you hit 75. Keep in the back of your mind, it might just be that this is what's happening, okay? There is, not long ago, the inner workings of the system were made public, and this is a fabulous piece of work. I would wholly encourage anyone to read it to get more details. I've attached here just one visualization that we have to sort of make sense of this. So if I take this case, there's the Chicago ORD data center and Toronto here, and you can see Toronto's smaller than Chicago, and as it starts to get busier and busier, it increases the flow of connections, that redirection to this data center. Similarly here with Montreal, you know, at some point Montreal is getting overloaded and it's sending stuff down to, this is Ashburn, I believe, okay? All right, now, I promised Jim and Christophe that I would stay in time in order to leave time for discussion. So there are a few slides in this next section, but there's a lot to say. And so I'm going to slow down. Knowing all of this, what are maybe some problems and opportunities looking ahead? Now, I'm going to emphasize these are personal views, but they are informed by things that are seen here and certainly interacting with all of the operations people. In fact, a funny anecdote, when I went to a number of them, I was sitting in a room and I said, hey, I'm going to talk to a few people about open problems. What are the things that drive you crazy that you wish could be different? And they said, almost unanimously, layer 8. My response to that initially was, what? And if you stop to think about it, actually what they're suggesting is really some of the hard problems that exist today are as a consequence of human expectations, or you know, this notion of expecting the internet to work the way other systems in the world work, and it doesn't. It's a global system. So let's talk a little bit about how this manifests. So the first big problem I claim is related to sovereignty and regionalization. I'm no fan of both of these labels. I like to call it localization. But when we were talking with Jim a couple of weeks ago, he pointed out, you know, that has so many meanings in itself. Not wrong, and I thank you, Jim, for pointing that out. So let's just call it what it is. The world is generally used to things like the energy grids, certainly the phone systems, and there's a notion of socio-political boundaries that exist along these things. Street address systems work the same, the postal system. And so trying to figure out people who have operated, and we have regulations and conventions that exist in this space, but now the internet has become a critical infrastructure in itself, oftentimes on which all of these other services apply, or rely rather. Now we have to ask, well, we want it to be global. It doesn't make any sense for the internet to look any other way than it does. How do we solve this problem? And I'll note, at least as far as I know, there are only two solutions that have emerged so far. The first is in the class of the logical operation. So we use DNS and regional routing to try and make sure that things stay in some particular region. But there's enough evidence and growing mounting level of evidence, it was a great SIGCOM, I think it was last year, that demonstrates actually when we do this notion of regional routing, it could have a negative impact on both resilience and performance. So this doesn't seem like a great thing to do. The other option is physical. And this is building whole new buildings and data centers and laying down whole new fiber and cables in the ground. And I'm going to note here, it requires a huge amount of money to do this and reshaping the planet. Neither of these is satisfactory to me, but we have yet as a community to devise any real alternatives. So I'm going to put forth that maybe we need to start thinking about a new design principle which is how do we enable data to be free to travel anywhere safely, such that there can be trust in where the data is going and or how it's processed. So just a couple of thoughts. There are minimum needs, perhaps. The first is packet authentication and auditability. From the old days of sort of the when we were talking about evolution versus clean slate network, one of the things that emerged and survived to this day is Scion. It flourishes in Switzerland. It's doing really well. And this might be one example of how we achieve layer 3 level authentication, okay? And notions of source routing. So even if it's true that you cannot dictate where a packet goes or doesn't go, which you can do with Scion if everybody's operating, at least it's possible to demonstrate where a packet has been. That has to be better than we have today. The second one, however, is this notion of client region. So we think of things like the EU. I know the US is thinking about this, and others around the world is how do we gate things? So I'd like to suggest that a terrible idea is to for regional governments to turn around to operators and say, hey, that fiber that goes to this destination, turn it off. The funny thing is, again, personal view, while those types of things, they're starting to emerge, and I know we're entirely aware of them, it turns out some of the bigger drivers for this right now are actually more client and service demands. So Private Relay is an example of this. Imagine Private Relay, this is the Apple product that people can sign up to, and it's a 2-hop oblivious proxy. So what that means is it's designed such that the only entity on the planet that knows both what you're requesting and your IP address is you. So Apple operates the first oblivious proxy. They know your IP address, but they don't know what you're requesting. The second oblivious proxy is operated by Fastly or Cloudflare or Akamai, and they know what's being requested, but they don't know by whom. Now, the interesting thing here is as a user, as a human user, I pick up my phone or I open up my computer and if I'm subscribed to this service and I say, hey, show me where the pizza places are near me, the server has no idea who I am. And so what ends up having to happen is we find ways of encoding the region or some notion of the location within the connection through the proxies, so that at the end of the day, the proxy can communicate something about where this thing is located, not whom, but roughly where. And that's because human users expect the system to behave exactly the same way, whether they're using Private Relay or not. The second, of course, need for this is notions of copyright. My favorite example is neither Netflix or Amazon Prime or any of these sorts of things where people have accounts and the content they view can change wherever they are. My favorite example of this is the BBC. So this is the public broadcaster in the UK. The BBC broadcasts for free to people in the UK, but cannot under any circumstances transmit data streams, video streams to people outside of the UK, even if they're UK citizens visiting some other place. And so oftentimes you can even try to connect into the UK via a VPN, and the BBC has to be conservative. And if it believes you're a VPN, it will just say, no, thank you. Okay. The regulatory is inevitable, it's growing, but it's not the right now version of this. So one open question is, how do we enable this? And surely it has to be at above layer 3, okay, for anything more than the layer 3 problem. There's a second thing I want to put out there, and I'm starting to wonder about if there is a new narrow waist that has emerged in the way the internet operates today. A lot of people think when they think about CDN-like services, they talk about centralization and other C words. I have to be honest, those I find are less and less productive to think about, in part because, on a personal level, I know of no example in human history where there is some big shared infrastructure that doesn't succeed or doesn't succeed without some form of coalesces, centralization, whatever the case may be. So let's think about what the internet actually looks like today in the context of these narrow wastes that have been useful to us in the past. The internet protocol stack, familiar to hopefully everybody in the room, puts IP at the center. Now, we tend to put transport and application and so on, and data link and physical below, but really, this stack reduces to end-to-end protocols above and point-to-point protocols below. And neither one of these, above or below, has to have any knowledge of the other side, as long as they both speak IP. IP is the interoperability layer that allows these things to succeed. A number of years later, there's a lovely piece of work that was published and said, you know, let's be honest, perhaps for better and for worse, when we think about writing networked applications, HTTP is now the new narrow waist in a sense, where the applications themselves are on one side. And I want to point out here, this is the clients and the servers. So it's not the clients above and the servers below. Both the clients and the servers above, they talk to each other via HTTP, and they don't care what's happening in the network. Okay. And this is what allows people to write internet applications. I'm going to point out here, by the way, that this stack here embeds notions of this stack here. It's not possible to do this without this one. Well, is there now a third stack? And for lack of a better label, I'm going to just throw out, this is the infrastructure services stack. And here's the rough idea here. And I would love feedback on this. It's the notion that there is a certain set of services that are provided by edge networks: caching, denial of service protection, firewall, zero trust, and perhaps there are others. And then there are devices on the open internet, and perhaps privately managed devices on the open internet. And then there are these backend services and private networks that really don't want to be exposed to the public internet. Okay. And so these groups here subscribe to services from these here. Now the question is this the new narrow waist? Again, it has to embed notions of HTTP and IP and so on to make all of this work. They're sort of embedded in the rightmost stack. But if this is what has emerged, then maybe there is an opportunity here. Maybe the way forward is to figure out what are the set of services, and how do we enable interoperability between them. My claim is this would have some nice side effects, not least of which is helping to quell or helping to address market concerns, because you wake up one day and you want to subscribe to service from one provider, and then the next day to compare against the next because of the interoperable nature, of course, which requires thoughts about the interfaces and so on, but also as a result fosters innovation. And this is the claim. So I'm going to put these forward and then just summarize. Cloudflare, the $0 egress might change the notion of value in the way we measure. The single software stack keeps us very aware of the way we deploy software into the data center and how it's organized. The 70% CPU, of course, means that everything has to be high performance, and we have to be very careful about the way the system operates. And then there's the whole notion of it's not even load balancing anymore, but it's sort of it's load shifting, as it were, and the powerful things that can emerge as a result of that. And then the open challenges, of course, is how to respect sovereignty and regionalizations independent of layer 3, and then edge service interoperability. So with that, I'm hoping I've left enough time for discussion to make it worthwhile. And I'm happy to take any other questions.
Okay. Wow, that was really, really fabulous. A really interesting talk. We're posting in the, if people would like to submit questions, comments, could be with your name on it, could be without your name on it. Christophe and I will help relay those to Marwan. So we really welcome everybody's comments and questions. Let me maybe, or Christophe, would you like to?
For some reason, I don't see the panelist questions in the webinar chat. So I just have the host. So, no, guys, it's time to move to Meet.
Okay. All right. Let me start. Actually, I had God, there's so much to say about those protocols, the stack pictures, not protocol stack pictures. I remember when I first saw that, some of those diagrams, I don't know, half a year ago or something like that, when we were talking about something else. It's really nice in the sense that I think everybody thinks about the stack on the left-hand side, protocol stack, but you now sort of thinking more broadly about, well, there's the applications. I totally get HTTP. And anyway, what's new for me is this notion of the applications and the users at the top who just, the open internet devices who, they're connected through edge networks like Cloudflare and Akamai. So I just want to say I have a lot of appreciation for this particular.
But Jim, every time I see a picture like that, I wonder why people are trying to keep this narrow waist picture. Meaning, maybe the internet has changed, okay? And there is no narrow waist anymore. So when I see this, I consider that an academic exercise. You try to show waist, okay? But think of it. Is there a waist anymore? Or is the waist still IP? So, or HTTP? I mean, I don't know. I mean, I wouldn't just try to do that. I'm a little bit surprised everyone tries to think that, the only thing that has not changed 4 years after the internet has started is the waste. I'd like to hear more people on that, but I wouldn't try that exercise. I think it's the internet has changed too much for that to be still a mental model.
I'll let you answer that.
So, I actually don't disagree with Christophe. I think that the sort of the motivation and the impetus for trying to devise this is to understand, if we think about the internet now as a bunch of operators together, how do they interact, and people focusing on whether things should have evolved this way or shouldn't have evolved this way. And I guess this is an effort to try and understand what is the way forward, if there is one. And so this seemed to me to be a familiar abstraction that people might be able to grab onto as a way to carry the conversation into the next step, which may be, Christophe, to your point, actually, it's not this at all, and there's something else, but maybe this is, the hope is that this might be a stepping stone towards wherever we need to be going.
So let me add in, I think that the notion of a waist and how narrow or how fat it is. Actually, I remember I gave a talk once about what happens to your waist at middle age when you hit 40, right? It's not this nice sort of narrow thing. You get love handles and things like that. But then a waist is all about interoperability, right? So it's what do you need in order for things above to operate with things below? So you need some kind of waist. It doesn't have to be a single thing. It could be a smaller number of things. But I think wastes are almost by definition needed because it defines how you implement the interoperability. And the narrower the waist, the less requirements you're placing on things on top having to operate with things below. And I'll say to Christophe also, who said, well, golly, it's 40 years, haven't things changed? Wastes haven't changed. Well, this picture shows me that wastes have changed, right? Because you're talking now, 40 years ago, there wasn't a lot of discussion about infrastructure services and how, if I'm writing applications at the top, do I worry about caching and DDoS and firewall and trust and things like that? So to me, if I look at this picture, I can see the evolution over 40 or 50 years from connectivity and IP on the left-hand side to services, caching, DDoS, firewall, all that kind of stuff on the right-hand side. So to me, the waste has been changing. That's one of the things I love about this.
Jim, if you define the waste as interoperability, things interoperate because of the IP address, no?
No, but I think what's important here, and I note there's a couple of questions in the queue, gentlemen. I'm going to note here on the left, and the reason this dotted line is so important, the left two stacks, they are technical, they are protocol defined narrow ways. A bunch of smart people get into a room, and by some form of consensus, we get to a place that say, actually, this is really great, and we all speak the same language. One of the challenges with the right waste is, in a sense, there's a human element attached to it, which is I know speaking personally, Cloudflare works really hard to Cloudflare wants people to subscribe to Cloudflare, some notion of value, not because they're stuck, not because they can't leave. And so there's even if this is true, how do we enable it, given that there's market forces that people want to compete? The best example I have of that, it was pointed out to me, given to me, is the CAB forum between the certificate authorities and the browsers. But that the tension between them is what makes them work. They're not equal players, they're different players. Here, everybody's on the same page. And it's sort of there's a non-technical, how do we make this happen? Or is it, if it's a good thing? I don't know. But it very much is about interoperability.
Okay,
Anyway.
we have a couple of comments and questions. Marwan, if you can see that, maybe we'll take the waste one first, since we're talking about waste, and then you could take the Cyan question next.
Okay, so let's see if in the Q&A window, is that right?
It's in the Q&A window, right?
Dave Varanz is first.
Well, John Crowcroft is the waste one.
John Doyle defined the waste requires and deconstraining constraints. Yes. I have no good answer for John. I'd leave it to John to point out. I have no good answer for this one. This is what I built. So
maybe you could repeat it. Not everybody can see the Q&A.
Oh, I'm sorry. So John Crowcroft has written, John Doyle defined the waste as requiring and deconstraining constraints. IP does this, so does DNA and ecosystems. HTTP, not so much. John, the best answer I have for you is that's part of the reason I think that I always say, for better and for worse, HTTP has become the narrow waste in the networked application stack. That's unfortunately the only answer I have. Hopefully that's okay. I'm sure you'll yell at me on Saturday if that's not true.
Okay, and maybe if you could take the Cyan question.
Okay, so David Aran says, since you mentioned Cyan, do you see this going all the way to the client end systems so the user policy on where to go is represented? Or is it deployed only at ISP edges via Cyan gateways? Dave, that's a great question. I would love to have that conversation. You know, there is this notion of, let's say we decide that the packet authentication, for example, that I mentioned here, where is it? That Cyan is a way forward for this, that there are people who have a need to demonstrate where a packet has been. What role do people here have, or even above and below for that matter? I suppose that the best answer is it's maybe driven by money in the end, because it's hard to imagine that every mobile device and every desktop computer is going to have a need to go this far. So maybe it's application based. As I understand, in Switzerland, hospitals and other healthcare providers are signing on to this, understandably so. Big portions of the financial sector are signing on to this. Maybe it's enough for the client AS or the client network itself to decide the policy about where packets should go. I'm happy to have that conversation. I think it's worth revisiting.
Great. Let me vector the next question to you from an anonymous attendee, and it has to do with the issue of sovereignty and privacy, right? And the question has to do. You talked about privacy. The only person who knows about me is me, and in the case of 4G and 5G cellular and 4G, you had an HLR for a home location register, for example, so that you, as a customer of whoever your mobile carrier was, the mobile carrier took care of things for you. And in the end, it may only be the mobile carrier who knows what you are, because if you go from 4G to 5G, that the edge network that you're attaching to now, a visited network, is more and more you become more and more opaque to it, right? It's really between you and your home location register, but there's this notion of something other than you that knows about you. And I think they're just looking for comments on that.
Yeah, so this is a much broader conversation. So I think it's worth, as a community, looking at the private relay, at the double hop. So the IETF has a suite of documents around this under the MASQ working group, MASQUE. And it's those ideas that private relay implements. The idea that we set up oblivious proxies such that only the client knows both what it wants, what it's trying to do, and its IP address on the network. Now, it's an interesting model to work with, But it doesn't, just because we can provide that level of privacy doesn't mean that it's going to be tolerated. Again, the regulatory is obvious. The less obvious is the notion of the pizza problem. So let me share with the room how this problem is solved today, and it's rather stunning. We tend to rely on geolocation for IP addresses, which, when we think about the anycast space, it's not even clear to me what that means, even if we could accurately geolocate IP addresses, which we know, we can't. We can do some level of granularity. But how then, if the connecting entity to the server, let's say the pizza place, how does it communicate out? Well, the way this happens now is Cloudflare and others publish openly a location for an IP address. And what we say is it doesn't matter where you think the IP address is, this is the location that you should attach to that IP address, so that when you decide to provide a service and you're using MaxMind or other databases, let's say, in order to understand where is the client, it is not where you think the IP address is, it's where Cloudflare says the location of the IP address is. And Cloudflare is not the operator to do this, by the way. This is a very broad practice. I believe there's even a couple of specs either emerging at the IETF or already in RFC status. I mean, okay, but that doesn't seem to me to be like an internet quality solution in the general case. Certainly, if you're missing a plethora of IP addresses, does this work? Does the scale? There are all kinds of onward consequences of this model. It just happens to be necessary in order to do this today. I don't know if that starts to address the question.
Yeah, I think so.
For me, this is the model we should be designing for, in a sense.
Mm-hmm. There's another question that came in. This is sort of a question about the basic architecture of Cloudflare. I'm just going to read it to you. Does Cloudflare deploy edge servers in local ISPs, or is it limited to data centers?
That's a
and maybe comment on that general question too.
So I suppose a part of this, there are reasons, as I'm not wanting to speak on behalf of other content providers who decidedly do this. Netflix's Open Connect is a great example of this. And it makes a lot of sense because it reduces Netflix costs, it reduces the ISP costs, and you're closer to the user and so on. I don't want to speak on behalf of the business, but what I can say is the default for Cloudflare is to be in a data center on its own. But sometimes the operating climate in different places around the world mean that you actually have to embed your devices within other people's networks. And that's just the way that it has to be done. So we think of these what we call partner points of presence, and this tends to be when Cloudflare puts its own servers in other ISPs. Generally speaking, it's reasonable to think about it that way, but it is a different level of access, and so the things like the IP addresses that can be advertised out to the rest of the world from those servers, for example, the reason this matters is because that tends to be influenced by what the network itself is willing to advertise out. And that's how it changes the operation.
Guys, there is a last question on the Q&A. Can you? We have 4 more minutes, so maybe we should do it and conclude.
It seems that. So David Aran says it seems location accuracy in services, internet services need to satisfy 2 properties.
There is one before. Did you answer the one before?
Yeah, he did.
Yes.
Okay, good. Dave Aran. Dave.
Number 1 is maintain a large enough anonymity set for privacy, and 2 is defeat the ability have a target missiles command. Interesting. It's a good observation. Yes. So how do you provide privacy and yet still know where to point? Maybe the key here is moving up a layer or 2 layers. Hard to say. I know there's this lovely little, a lovely new mechanism that's emerged at the IETF called Privacy Pass. That might be the beginnings of something. Its application layer, it's unclear to me. But certainly, personally, I would say if we want perfect privacy in the world, then likely we're going to have to either sacrifice some notion of location or attribute about where we are, or accept a degraded level of service. That's my sense.
I mean, I personally would question even the anonymity for privacy. Okay.
Yeah. How do we define anonymity? I think that's right. Yeah.
Yeah, I'm bitter. I don't believe in the privacy thing. I mean, I agree on the second one, but that's not probably something you want to manage with privacy. Okay, that's something you want to manage with a proper tool to avoid that to happen, but not by privacy. But that's a personal comment. Okay, guys, we're at 2 minutes before the end. So if there is no more question, I propose to stop there, not only because they have a meeting starting in 2 minutes, but
Okay,
because
so
that's the rule, and we can continue on Slack.
great. Yeah, let's continue on Slack. And Marwan, we want to thank you again for just a really thought-provoking and really information-rich also presentation. Can you give up your screen sharing? I just want to put up a slide about our upcoming event. Great, thanks a lot.
Thanks for
Yeah, and you're so much better as a square on the top.
Okay, so thanks again, Marwan, really fabulous. And we're now in our 5th season for the networking channel. Our next event, so we're always doing this time on every other Wednesday. The next upcoming event is shown here. What network connectivity, I think, to achieve or to super connect the connected and bridging the digital divide between developing and developed nations. And you can see Bamba is the organizer of that. You see him on the right-hand side, and you see the panelists that we have. So I think it's going to be, again, another great event. So that's in 2 weeks. And again, Marwan, thanks again so much for this. It was really super. Okay, 12 o'clock. Bye-bye, everybody.
Thanks,
Thanks,
Marwan.
John.
Excellent presentation.
Thank you. Good seeing you both. Good seeing you both. I hope we get to continue the conversation.
Yeah. See you on Slack.
Okay.